All right, I'm just going to look at three different examples of problems that involve derivatives before we get into our review sheet and move on to our test. So the first example here, it says let f of x equal f of g of x. Now this is important, okay? Sometimes it may say the following, f of x equals f composed with g of x. Either or, this means the capital F of x is a composite function. And with a composite function, we must use the chain rule. Okay? So let me say that again. F composed with g of x, or f of g of x, that's what it means, f composed with g of x. This also means the same thing. Notice the dot is an open dot. That doesn't mean the product. It's not like the product rule. It doesn't say f times g. The open dot means f composed with g. If in order for it to be a product rule, it would have to look like this, okay, with a solid dot. When you see the solid dot, that means you're using the product rule. All right, now that being said, we have to remember that if f of x, sorry, I'll do this in black, if f of x is equal to f at g of x, then remember for the chain rule, the notation looks like this. F prime x, or capital F prime x, is going to equal f prime g at x. So this is the derivative of the outer function. Of outer function times g prime x times the derivative of the inner function. And that's how the chain rule is set up. All right. Now they actually want me to find this. They want me to find capital F prime 1. Well, that's no problem. All I would do is I would take this notation and I'm going to replace those x's with a 1. So capital F prime 1 is going to equal F prime g at 1 times g prime 1. I don't overcomplicate this, okay? All I did was I filled a 1 in for the x's. Now, I'm going to do this slowly. I'll do it one at a time, but you could actually evaluate this first. But let's work on this part here, this derivative of the outer function. Well, what does g at 1 equal? So I'm going to change this so that it says f prime, and then I'm going to replace that g at 1 with something. And then I'm still going to multiply by g prime 1. Okay, so g at 1. If I look at my list up here, I can see that g at 1 is equal to 2. So this f prime g at 1 can now read f prime 2. And from here, it's just going to be the multiplication of these two things, f prime 2 times g prime 1. So let's try and figure out what f prime 2 is and what g prime 1 is. So if I go back up to the list, f prime 2, that was this thing, or that's equal to 5, and g prime 1, that's equal to 4. So f prime 2, I can replace that whole thing with a 5. And g prime 1, I can replace that whole thing with a 4. So this is going to become 5 times 4, which is pretty simple. 5 times 4 is just 20. So capital F prime 1 would be 20. Okay, that's just another way of doing a problem with derivatives. And you can do these problems with the product rule, quotient rule, or chain rule. All right. In order to do it with the chain rule, I would have need to have known, they would have had to give me f at 1 and f prime 1 as well, because I have g at 1 and g prime 1. I could have used the product rule. Same thing for quotient rule. I need f at 1, f prime 1, g at 1, and g prime 1 in order to find f prime 1. And in order for it to be a product rule question, it would have to be written like this. A quotient rule question would have to be written like this. It would be f divided by g of x. All right, on to example 2. Now, this one, there's a couple ways to do this. I'll show you one. You can check the other. On the next slide, you can choose which one you prefer. All right, with example 2, they tell us two functions. They tell us y is equal to u to the 10th plus u to the 5th plus 2. They tell us u is equal to 1 minus 3x squared. They want me to find dy over dx when x equals 1. So I'm going to do first, I'm going to find the derivative of this. And I'm going to use Leibniz notation. The derivative of y with respect to u would be dy over du. This is just a simple sum and difference rule question, all right? The derivative of u to the 10th would be 10u to the 9th. The derivative of u to the 5th would be 5u to the 4th. The derivative of positive 2 would be 0. Okay, so there's the derivative of y with respect to u. Step 2, I'm going to find the derivative of u with respect to x. So I'm going to find the derivative of this second function. And using Leibniz notation, I'd call it du over dx. It's going to equal, well, the derivative of 1 would be 0. The derivative of negative 3x squared would be 2 times negative 3, negative 6, x to the first, 2 minus 1. So negative 6x is my derivative. Now, I'm going to call this step 4, and I'll show step 3 over here. I'll start with step 4 because it's going to kind of lead me to figure out what I need to do in step 3. So if I want to find dy over dx when x equals 1, that's telling you to fill a 1 in for the x's. Here's what I can do. I can take step 1, dy over du, and I can multiply it by step 2, which is du over dx. Now think about why that would work. Well, dy over du times du over dx, essentially, we can get these things to cancel, and it would leave dy over dx. Okay, so let's write this down. Dy over dx when x equals 1 is going to equal dy over du, so step 1. What did you get in step 1? It was 10u to the 9th plus 5u to the 4th times du over dx, that's negative 6x, that's step 2. All right, so this times this. Well, in order to solve this, yes, I could fill an x or replace the x's with 1s, but the problem is, what do I fill in for u? Okay, and that's where I can do step 3. You might notice that I have this equation up here, u equals 1 minus 3x squared. Okay, u equals 1 minus 3x squared. I can solve for u by plugging this 1 in for x. That same 1 that I'm going to plug down into the step 4 in for x, I'm going to plug it in for x into this step 3, and it will give me my u value, and then I can plug that number in here. So I end up with u equal to 1 minus 1 squared is 1 times 3 is 3. 1 minus 3, u is going to equal -2. So now I know my u value. And again, where did this come from? Right here. Okay, I was able to figure out what u was by filling this x value into this equation. And now I'm ready to rock and roll. Okay, now I can work this problem out. dy over dx when x equals 1 is going to equal, so this would become 10 times -2 to the 9th plus 5 times -2 to the 4th, and then -6 times 1. Okay, so I'm filling a 1 in there, and I'm filling -2's in for the u value. So a 1 goes here, and a -2 here and here. Okay, this x value is 1, it's this u value -2. So replace those variables. Now I just got to work it out. -2 to the 9th, that's -512. Okay, -512 times 10 is -5120. -2 to the 4th, that is +16. So I'm doing my exponents first. Multiplying by 5, 16 times 5 gives me 80. And then in this bracket, -6 times +1, I get -6. Work this out, -5120 plus 80. That's going to give me -5, oops, -5040 times -6. Multiply those together. So 5,000 negative times a negative would be positive. 5,000 times 6 would be 30,000. 40 times 6 is 240. I end up with positive 30,240 for my final answer. Okay. Now, I would suggest going through it this way for the most part. Okay, I would do most of my examples this way, where I would do the derivative of this first function, the derivative of the second function. I would find this variable for the second function, and then I would multiply step 1 and step 2 together. Okay, the 10u to the 9th plus 5u to the 4th times -6x, and I'd fill in my variables. I filled in my x as 1, and I filled in my u as -2. That's always an acceptable way. However, it's not always the easiest, okay? It's fairly straightforward. It's a legit, solid way of doing it. But some people may have chosen a different way to do this. And I'll give you a second now to think of how you could do this. If you want dy over dx from the beginning, think about what you could do with these two functions. All right, if you suggested filling these u values, or replacing these u values with 1 minus 3x squared, you'd be on the right track, because then you would have a function right here that is y written in terms of x, and if you differentiate that, you would end up with dy over dx. So that does seem like an easier method, and that's what I did over here. Okay, I substituted 1 minus 3x squared in for u. I changed the original equation, y equals u to the 10th plus u to the 5th plus 2 into y equals 1 minus 3x squared to the 10th plus 1 minus 3x squared to the 5th plus 2. So I replace the u's with 1 minus 3x squared. And then when I differentiate, I can just do the derivative of this function, would give me dy over dx. Remember, the derivative of y with respect to x in Leibniz notation is dy over dx. To do the derivative of that, I have to do a chain rule. So it would become 10 times 1 minus 3x squared to the 9th times -6x. Chain rule again, 5 times 1 minus 3x squared to the 4th times -6x, and the derivative of 2 would be 0. I collected my like terms here. Sorry, I multiplied to kind of clean this up a little bit. And then I would just sub in a 1 everywhere there's an x. All right, so I replaced all the x's with a 1, and I ended up with 30,240. Also another acceptable way of doing that question. The problem with this way, all right, is that here I was combining a polynomial function, or I was placing a polynomial function within another one. If you get a rational function here, or you get some sort of other complicated function that you plug in here, well then this derivative right here gets a lot trickier, okay? And when that's the case, I would suggest going this route with it. Take the derivative of this function, the derivative of this function, and then multiply them together. Either or gets the same answer. Last one says determine the equation of the normal line. So there's something we need to know. We always did tangent line, all right? Determine the equation of the tangent line. So we'd find the derivative, we'd plug in our x value to get the slope, and then we'd go with the equation y minus y1 equals m onto x minus x1. Still going to do the same thing, all right? There's just something important to know about the normal line. The normal line is perpendicular to the tangent line. So we need to know something about perpendicular slopes. So think reciprocal, opposite reciprocal. I'll show you what to do in step 2 or 3. In this case, I'm going to call it step 3 because the first thing I need to do here is to find y. I already got x, but I need y. Remember, I need to use the equation y minus y1 equals m onto x minus x1. So for step 1, I'll say find y. So in order to find y, I'm going to take my original function that says y equals, could say f of x as well, 1 minus x, and I'm going to replace the x with a negative 3. Okay, I'm filling this x, negative 3 in here. And I end up with, well, 1 minus negative 3 is like saying 1 plus 3, so it's 8 over 4. I get y equal to 2. Now, step 2 is where I would find the derivative. Now, in order to do this derivative, you could use a quotient rule. I would rewrite this function as 1 minus x to the negative 1. I'm bringing that up to the top, and now I'm going to do a chain rule with this. So y prime, Newton notation now, I'm not using dy over dx. You still can use dy over dx if you like. All right, y prime is going to equal negative 1 times 8, negative 8. Rewrite your base, 1 minus x, subtract 1 from the exponent, negative 2, and then you multiply by the derivative of what's inside the bracket. So this is a chain rule question. Rather than using the quotient rule with this, I rewrote the function so I could use the chain rule. And the derivative of 1 would be 0. The derivative of negative 1x would be negative 1. When I simplify this, I get negative 8 times negative 1 gives me positive 8. And then I send the 1 minus x to the negative 2 to the bottom and make it a positive 2. So there's the derivative. Step 3 is to find the slope. Well, remember, in these previous questions, you've seen these questions all the way along, whether you were doing the power rule, product rule, quotient rule, or chain rule. But to find m, I am going to take the derivative, this function right here, and I am going to replace the x with that same negative 3 that I did in the beginning. Okay. Remember, we said right from the beginning of this section that if you plug x values into the f of x or the y equals equation, you get y values, you get heights. If you plug x values into the y prime equation or the dy over dx equation, you get slopes. You get the slope of the tangent line. So this would become 8 over 1 minus negative 3 squared. Okay, just to make sure everyone's clear with that, where that -3 is coming from. That was given to me. So I end up with y prime equal to 8 over, this is 1 plus 3, gives me 4 squared. So 4 squared, that means 4 times 4, gives me 8 over 16, gives me y prime equal to 1/2. 8/16 is 1/2. And that means m is equal to 1/2. Now keep this in mind, that's not the slope I want. The normal line, we said, is perpendicular to that. So the slope I should use would have to be the opposite reciprocal of this. So the opposite of a positive is a negative. The reciprocal of 1 over 2 would be 2 over 1, which is -2. So I've got my x1, my y1, and my m value. So step 4 is to find the equation of a line looks like this. So I want to find the equation. And remember, the equation of any line is y minus y1 equals m onto x minus x1. So y1 is what I was given, or sorry, what I found in step 1. That's this 2. M is what I found over here in step 3. That's my -2. X1 is what I was given in the beginning. That was the -3 up here. Okay, so I'm going to write y minus 2 equals -2 onto x minus -3. And away I go, I can solve this. And you can write it in standard form, general form, slope intercept form, whatever blows your hair back. How about that? I know the textbook usually writes them in general. Okay, so this would be y minus 2 equals -2 onto x plus 3. When you multiply through the brackets, you get y minus 2 equals -2x minus 6. Now, I'm kind of partial to slope-intercept form. So -2x, if I add 2 to both sides, I get -2x minus 4. That's where I would leave it, okay? The textbook puts it in general form, so they bring the -2, they bring it, instead of bringing this, adding 2 to both sides, they bring everything to this side. So they'd have a positive 2x, a positive y, and a positive 4 equal to 0. Both are acceptable with me. You choose which one you like best. How about that? Okay, and that is that. So we'll begin our review, and hopefully you would be ready for a test at this point. Keep an eye on the Teams page, all right? I will be posting some worksheets for you in there.